Hi, Frank McKenna again, UC Berkeley, working for the Near East Sim Center. In this video, we're going to have a short video on how the operations, conditions, and loops in C. Basically, how do we work with data in C? Operations, we want to do stuff on the data. Previous videos just showed you creating characters, ints, and floats and printing them out. That's actually not doing very much. Now we want to start working with the data. So that's where operations come in. We've got the basic arithmetic operations, plus, minus, times, divide, and modulo. This is example op1.c in the source code. That'll just take some numbers. We're assigning, initializing variables a and variables b, and then we're initializing variable c to be the sum of variables a plus variable b, and then we're using our printf to print them out. Printf again, this time it's taking 4 arguments. First argument that is that format string. It'll take a %d, 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 and it just plugs in what a, b, and c are. Again, we want to return a value from the function, so we're returning 0. Now we can string operations together. It's not just a times b. You can actually do more than that, a plus b times 2, or a times 2 plus b times 2. The question is, what is the result of this? Is it a plus b and then multiply the result by 2, or is it b times 2 and the result plus a? As you'll see, there is a precedence table so that the function is defined. It's not arbitrary. But for easy read, I suggest you always use the parentheses to define just exactly what it is you want. So again, that opera precedence table, this will define what the statement will actually do. Now, some of the operations are so common that there are special operators for them. For example, adding 1 to an integer is very common. So you can go a, instead of going a equals a plus 1, you can go a plus equals 1. That will do that same effect. And then again, you can also just do a plus plus. It's even easier. Use a plus plus when you're incrementing by 1, and then the a plus equals something when you're incrementing by more than 1 is what people typically do. So now let's look at some conditional code. The first thing, if statement, widely used, of course. If the strain is less than a certain amount, do this, otherwise do something else. The way we do it is we put it, the if statement, we've got some condition, and then we have some code block. So here's an example, a equals 15. If a is less than 10, it's going to do this. If a is equals to 10, it's going to do this. And then if a is greater than 10, it will do this. And here are the conditional operators that are available to us. Of course, this is pretty wasteful code in that it's going to evaluate each of these conditions once. So a much more efficient way to do it is to use the if-else, or the if-else, else-if statements. Greatly reduce the number of operations that are actually performed. Again, C, we want to be write as efficient code as possible, and if we're using if-elses, it's much more efficient than an if statement. Logical operators, and, not, and or. The first one here is the and, this is the or, and this is the not. Similar to Python, I'm just basically showing you what they are. Something I don't think you saw in Python, we have a switch statement in C. It'll switch on some variable. We can switch on variable. If it's equal to y, we do one thing. If it's equal to lowercase y, we do something else. So this is the example, and here is the basic usage. Iteration. We do a lot of iterating. We iterate over all the contents of a vector. So the way we do it in C, we have the while statement. The while takes some condition, and then we have the code block inside these curly braces. While the condition is true, we'll remain in the code block. So this will evaluate the condition at the start, and then while it's true, it will keep looping into the statement. So here we're setting count is equals to 0, and we're iterating while count is less than 5. Of course, a very important thing when you're using a while loops, you need to break out of the while loops, otherwise your program will go into an infinite loop. So if you're using a while loop, always make sure that there's going to be some way of breaking out of that loop. If you do enough loops, you recognize that they follow the same pattern. There's some initialization of some variables. For example, we're initializing count equals to 0 and sum is equals to 0. Then there's some condition we're going to test, and then we're going to increment by some value. So a quicker way to do it is to use the for loop. So this is the for loop. the for loop takes some initialization statements, then does some condition, and then some increment. So here's a for loop. We're doing the same thing as we did previously for int sum is equals to 0. And then we're going to start off where count is equals to 0, count is less than 5, and count plus plus. So if we look at the previous code, it just looks better, the code. So that's the typical, while is not commonly used when we're iterating over a number of known values. We use the while when we don't know when, we're not sure when we're writing the code when that while statement will be satisfied. For example, if we're doing Newton-Raphson iterations, we'd use the while loop. While we haven't converged, keep trying to converge. But if we're doing a dot product on a vector, we're going to use the for loop. Now, the nice thing about the for loop is in that initialization phase and the increment phase, we can initialize and increment multiple values. So here I'm just initializing the variables I and j, and then I'm incrementing I and j in the same place. So before I quit, I thought I might do a little demonstration of using a for or a while loop in a program and actually doing something useful, reading something from the input and doing something based on the input. So let me go to let's go to my terminal. So here is my terminal. I'm in my temp directory again. Let me make dir factorial, cd factorial. I'm going to Emacs a file, Emacs factorial. I do not, of course, have to call the file. I just demonstrate. I don't have to use the same file name in the directory. So here's I'm emacting fact.c. So this usual stuff, I'm going to include standard I/O for my preprocessor. I am going to create a main function. I'm going to take int arg count char pointer argv, start and end the thing, return a 0 when I'm done. So what do we want to do? We want to do factorial of a number. We need a number n, we need an integer. I'm going to initialize it to 0. We need to go get that integer, so I'm going to put out a little statement, printf, not file printf, we'll see that tomorrow. Printf, enter a number. And here's something new. We're going to do scanf, %n, %d. We're going to read in an integer. And here's where we're going to pass in the address of n. So to scanf, we're passing in the address of n. And then we're going to go calculate the, let's do a comment here. Let's do the while. So how do we use a while? We got an int count, set it equal to 0, int sum or int factorial, also set that equals to 0. While count is less than n, actually less than or equals to n. What do we want to do? We want to say the factorial equals fact times count. And of course we want to increment count by 1, so we'll just do count plus plus. Now this isn't going to work, because if I multiply by 0 for the first one, I'm going to get 0. And if I multiply anything afterwards by 0, we're going to get 0. So we're going to start the count at 1, and we're going to start our factorial at 1. So we're just going to do printf result using while is result of so we're going to to pass it an n, and we're going to pass it factorial. So that hopefully will work. So I'm going to Control XS, save that file. Yeah, let me do something else here. Normally I'd save it, we'd exit, we'd compile it, we'd run it. Let's do something. I'm in Emacs. I'm going to do Control X3. That's going to split my screen vertically. I'm going to do Control XO to go from one screen to the other. It's just Control XO. Inside this other one, I'm going to do Escape X shell. And that's giving me a shell. And now here, if I do an ls, I'm going to see I've got factorial, so I can gcc factorial.c, and I will get my application. Let's run that application. Let's enter something I know. 3 factorial should be 6. There we go. Let's try something bigger. Run it again. We'll try 4. 4 6s are 24. Perfect. So that's our factorial with our while loop. So let's do it with for loop. So how can we do this one? We can do this. We can do a for int count equals to 0. A count equals 1, remember? We can also use sum equal, factorial equals 1. Sorry, that should be a comma here. We're initializing. We want n count less than or equals to n. And we're going to increment with count plus plus. And we are going to, so let's do times equals count. So here you see I'm using a times equal instead of this one here. So we're allowed to do it. And then we'll printf this again. So we'll just go up here. We're going to go control K, control Y, come down here. Control Y to paste that in. That's the same thing. We'll just change this to 4. So control save that. Control XO. Compile it. Fact.c, run it, a.out, enter number 4. So they both give 24, which is good. But as you see, I think the for loop looks a little bit cleaner. We can do that multiple initialization. Again, I'm using that times equal, make it a little bit shorter the code for me to write. It's still understandable. We don't need the count plus plus. Just demonstrate what happens when we don't have count plus plus. And I'm going to do this outside of Emacs. So we've saved that now. If I cat the file, just to show you that it's got that, we've commented out. I've done a C comment. So let me change that. Or C++ comment. We're programming in C today. There's a C comment. One thing about comments, let me quickly show you. That comment, it doesn't necessarily do one line. You can do as many lines in here as you want. They're all treated as a comment. So here now we've taken out that count plus plus. So now we're going to go into an infinite loop because count is always going to be less than n because count is always going to be 1. So let me gcc fact.c. Compiler's not going to catch it. And then when we run it, here we enter the number, and now this thing is never going to die. So to kill it, we have to do Control C, and that killed the program. And if you want to see that we are actually in an infinite loop, let's throw inside the while loop a statement printf %d, %d, print out the count, and the fact. And we will see when we run this that d should always be equal to 1. Oops, I didn't compile it. There we go. Control C, kill it. Okay, so let's go back to the PowerPoint presentation. I have a little exercise for those of you who are interested. So here is the exercise. Basically, I want you to write code to count the number of characters in a file. So you're going to create a file, count.c. You're going to compile the file, and then you're going to run the file, and you're going to run it this way here. This ./a.out, that's running our application. And I want you to do is use this less than sign. So a space here, less than sign, a space, count.c. And what that will do will send count.c as the input to the program. So the c equals get char will be reading all the characters in the file you pass it in. So we'll be counting all the characters in this file. And the characters we're not going to count are spaces, /n's, and /t's. Basically, we want to see how little code you have to write to perform the exercise.